Agricultural inspectors play a critical role in protecting pollinators and keeping bee colonies thriving. These inspectors perform tasks intended to keep farms safe and compliant by enforcing pesticide labels, pollinator-safe practices, and other agricultural regulations. This requires the inspection and evaluation beginning with apiaries and their colonies, especially when there are concerns about colony health. But what does a healthy hive look like? The physical structure of a standard beehive may seem very basic, but each component serves a specific function that contributes to an active and positive environment for the bees. The top cover simply serves to protect the hive from the elements, keeping out rain, snow, or other debris. While there are many ways to feed bees, in this hive configuration you see a hive top feeder. These are useful throughout the year when floral sources are lacking. They're also great at keeping food sources safe from other pest insects or bee colonies outside of the hive. A honey super is any box above the brood chamber where bees store honey. On this colony, you see a medium-sized box that is 6 5/8 inches. During honey production, you might see multiple honey supers on each hive. In this hive, beneath the honey supers, you'll find a queen excluder. This is primarily a grid made of plastic or metal, with gaps that allow workers to move between honey storage and brood boxes, but will keep the queen from wandering into the supers and laying eggs. Brood boxes are the deepest boxes or sections of the hive and can normally be seen on the bottom of the hive structure. This is where workers will build comb for the queen to deposit her eggs for larvae and pupae to develop. Some of the comb in the brood box is used by workers to store pollen, nectar, or honey to feed the developing brood. The bottom board is the base of the colony. It may be screened or solid. This hive depicts a screened bottom board. The bottom board has a small entrance space for bees to come and go easily. The entrance is limited to protect the hive from intruders, and it's not unusual to see bees crowded at the opening, pushing out old, diseased, or dead bees, as well as other foreign objects. What does a typical apiary inspection look like? Having the beekeeper on site during your inspection is highly recommended. This will reduce the potential for any future miscommunications and help involve the beekeeper in the investigation process. While each site is different, there are a handful of common tools and practices that the inspector will use in the process. The first is a standard hive tool, a long, thin piece of metal resembling a small pry bar. The hive tool is used to help separate hive box layers, loosen stuck hive parts, such as supers or frames, and scrape excess wax or propolis, also known as bee glue, from those same parts. The most essential tool is the smoker, a metal cylinder with a bellow attached. The smoker is used to knock at the door, to let bees know that you'll be performing some actions in and around the hive boxes. The smoke will mask the pheromones bees use to alert each other in the hive. This results in a calmer temperament within the structure. The smoker is also used to move bees away from the edges of the hive boxes or frames when reassembling the hive. This reduces the likelihood that bees will be pinched or crushed between the hive layers. Now that we know about the basics of hives and the tools we need to investigate, let's talk a little bit about the safety measures needed to protect inspectors and bees. First, take note of where the main entrance of the hive is located and make sure not to stand in front of it. The bees will only see this as an obstruction to their established traffic patterns and may become agitated by having their passage blocked. Make sure your movements are slow, calm, and intentional. Steady, deliberate movements with vigilant attention to hive activity are best. Wear protective clothing. Bee veils and other apparel such as jackets or full suits help you stay protected and remain calm while working in the hive, which is critical in helping the bees stay peaceful. Though many prefer to work barehanded, nitrile gloves offer an alternative, as their flexibility allows you to work in tight areas with dexterity and may provide some protection from bee stings. Nitrile gloves will be required to maintain sample integrity. Listen to the hive. Take into account the intensity of the buzzing. In addition to the release of alarm pheromones, buzzing is how bees will communicate perceived threats to one another. Buzzing is a good way for inspectors to determine the mood of the bees. Does their buzzing seem agitated? Is it increasing with your movements? If so, perhaps additional smoking or a later visit is called for. It is best to avoid opening the hive early in the morning or late in the evening, as well as visiting during inclement weather. Sometimes, despite our best efforts, we still get stung. If you know you're highly allergic to bee stings, simply don't go to the apiary. If you do get stung, get immediate medical attention if the reaction seems severe or is causing other physical symptoms such as shortness of breath or throat tightness. Scrape the stinger out of your skin with a fingernail or hive tool. This will remove any pheromone left behind after you've been stung. When it becomes necessary to investigate a bee kill, it's important to observe the environmental factors that may be at play. Carefully examine the area around the hives for any of the following. Check local forage sources for the hive. Where are the bees gathering food and water to sustain the hive? Bees normally travel 2 miles to forage, but can, in extreme cases, travel further to look for resources. Use the hive as a starting point and radiate out when looking for potential sources of harm. Look for sources of supplemental feed. Feed that is contaminated could be a potential source of pesticide exposure. Identify nearby crops and their relevant stages of growth and bloom. Ground covers, weeds, and field borders in bloom may also be forage sites for bees. Would seasonal pesticide use correspond with flowering? Could bees be visiting a site that has recently been sprayed by pesticides? If an area is found that looks like it may have contributed to the bee kill, investigate further to determine if pesticide was used correctly with regards to rate, timing, drift, and areas that bees may be using for foraging. Look for evidence of pesticide spills, recent landscape applications, or structural applications to nearby buildings. Where are bees collecting water? Bees may collect water from places we wouldn't think to look as humans, such as mud puddles, drainage areas, condensation lines, and agricultural mixing and loading pads. Take note of the beekeeper's practices. Are pesticides being used to control hive pests? Misuse of pesticides in the hive can also lead to adverse effects, including a bee kill. Are these bees managed by a commercial or hobbyist beekeeper? Commercial bees are often moved to various locations throughout the year. Where have the bees been located, and could they have been exposed at their previous location? Is there evidence of starvation or poor hive management techniques? Determination and good observation skills will help you examine the possible causes of the bee kill. If pesticide involvement is alleged or suspected and could be a factor, the following elements should be considered. You can remember these using the acronym TED, which stands for toxicity, exposure, and dosage. Toxicity. The product is known to be toxic to bees. This may be indicated on the pesticide label's environmental hazards section. Exposure. The bees must contact the pesticide. Bees must be present or foraging in the treatment area of exposure through drift. Dosage. The bees must be exposed at a dose that can cause harm. The product was applied at quantities sufficient to cause adverse effect to the hive. If a pesticide exposure is suspected, the next stage is to properly collect samples for laboratory analysis. Make sure to follow your state guidelines when sampling in order to preserve the accuracy and integrity of the investigation. Basic tools for sampling may include a small probe to collect material from hive cells, a spatula, alcohol swabs, and sampling bottles. A small roll of electrical tape is handy for sealing sample bottles after collection. Document your observations. Take photos of the number of dead bees present at the hive. Your observations will determine the type of sampling you do. Samples may consist of dead or dying bees, honey, pollen, swabs of hives, soil and vegetation samples in the proximity of the hives. Take note of the amount of dead bees found inside and outside of the hive. Bees will push dead or dying bees out of the hive. Consider how many bees are necessary for a sufficient sample. Sample bees that are freshly dead or dying, not bees that have been left to decay. Dead bees found on the bottom board will be the most ideal bees to sample. Gather a fresh sample of pollen. Newer pollen is typically drier, looser, and closer to the open brood. Older pollen appears glazed over and packed tighter and more firmly into the cells. Avoid older pollen as it may not contain recent residues relevant to the exposure being investigated. You may need to take pollen from multiple cells and frames. If pesticide drift or exposure is suspected, it is also recommended to obtain swab samples taken from the outside of the hive, including the hive entrance. Depending on the suspected drift direction or proximity to the field, the sample may be taken from the top, front, or sides of the hive for analysis. When sampling the top of the hive, a metal top is an ideal location as opposed to a wooden migratory top, which may be contaminated from hives stacked on top of each other. Some labs will not process honey samples because it is difficult to examine sticky substances. Check with your state guidelines to determine the proper amount to sample, if any. Occasionally, a beekeeper may collect the sample to be analyzed. Make sure that your state guidelines permit samples gathered by the beekeeper. Follow state-required chain of custody guidelines when gathering any and all samples. Clearly mark appropriate date, time, and location information on all sample containers and evidence bags. This is critical for the accuracy and integrity of any investigation. Any shipment of samples should also follow the requirements outlined by state SOPs. The proper completion of every step in a bee kill investigation ensures the case is defensible and allows regulators to follow through with any enforcement action that is warranted. Bee kills are not always the result of pesticide-related activity. When used properly, pesticides can be a useful tool for crop protection, and their use for protecting bees is no exception. If pesticides are suspected, it's best to wait for any and all laboratory test results to confirm case outcomes. If the kill is related to anything other than pesticides, proper colony management may need to be reviewed. Hives are also the target of pests, such as varroa mites and small hive beetles, or SHB, and attacks from other animals. The key is to always carefully observe and examine the presented evidence. Varroa mites are an external parasite of honeybees that only reproduce in honeybee colonies. They attack adult bees, as well as developing brood or larvae. They can cause decreased brood numbers, activate, transmit, and amplify latent bee viruses, which can cause bee deformities and, if untreated, will lead to a general weakening of overall hive health, parasitic mite syndrome, and colony loss. At any given time, up to 2/3 of the mites will reside in the capped brood stage, making it difficult to detect during hive inspections and know how bad the infestation may truly be. Heavy infestations can manifest quickly and ultimately lead to hive collapse or death of the hive. That's why regular monitoring and effective and approved treatments are essential. Another pest for beekeepers is the small hive beetle. One sign of small hive beetles is damaged or destroyed brood combs, as the beetles will burrow through combs, causing extensive damage. Small hive beetles will also eat honey stores and contaminate them. Contaminated honey stores will appear slimy and have a distinct smell similar to rotten oranges. In some crops, the production of fruit or vegetables could not be done without pollinators. Likewise, bees need healthy flowering plants to feed the colony. Safe, sustainable, and legal use of pesticides by beekeepers and growers is critical for all. The partnership between beekeepers and the wider agricultural industry is essential for the production of food to sustain our population and planet. With the combined stewardship of the beekeeping community and agricultural inspectors, we can continue to protect pollinators, promote a safe honey supply, and protect the beekeeping industry.